Good day and dangal greetings. I am James YUAN DALMACIO, the leader of this group, and this is our OOP midterm project, a smartphone simulator and of course built using Java. The goal of this project is to simulate how a smartphone works throughout the day, sending messages, making calls, browsing the internet, playing music, and taking photos. Each activity represents a different object collaborating with another object inside the system. The project demonstrates the four core concepts of object-oriented programming: the abstraction, encapsulation, inheritance, and polymorphism. Our program is made up of 12 classes, each with a specific role. Later on, you will see how CAISTLER fully demonstrate our program. But now, let us explain the foundation that makes it all work.
Hello everyone, my name is CAISTLER Joseph Escueta and thank you Uno for the introduction. So UML diagram is the bird's eye view of how the entire system is structured, what classes exist, what they contain, and how they relate to one another. So before we even look at the code, this diagram tells us the complete story of the design. So the application class is the top of that hierarchy. At the very top of the diagram, we have the application class. This is an abstract base class. So and it sits at the top because every app in our system is built from it. It holds a protected attribute called appName, a constructor, a getAppName method, and two behavioral method which is open and execute. So the execute method in particular is meant to be overridden by every subclass, since each app has a unique function to perform. So the five subclasses, which is the inheritance, is in action below the application class, connected by inheritance arrows. We have the five concrete app classes, which is the browser app, call app, messaging app, camera app, and music app. Each one inherits that structure of application and provides its own implementation of open and execute method. They also each carry their own attributes depending on what hardware they need, which is the browser app and call app and messaging app. Each hold a reference to a network module since they all require data connectivity. So camera app holds references to both a camera and a storage since it captures and saves photos. Music app holds reference to both a speaker and a storage since it loads and plays audio files. So the hardware classes, which is the composition, on the lower portion of the diagram, we have the hardware subsystem classes, which is the network module, camera, speaker, and storage. By the way, this is not apps, they are the components that the apps depend on to function. So the smartphone class at the bottom center owns one instance of each of these hardware components. This relationship is shown through composition arrows, meaning the hardware exists as part of the smartphone and is managed by it. So next one is the smartphone class, which is the core of our code. Finally, itself ties everything together. It holds a power status, which is Boolean, a list of application objects, and individual references to camera, speaker, network module, and storage. So its three key methods are start phone, install app, and open app, which are exactly the methods called in the main to drive the entire simulation. So, in summary, this diagram shows us a system built on two core object oriented principles, which is inheritance through the application hierarchy that unifies all app types under a common structure, and then composition through the smartphone's ownership of its hardware subsystems, which are then shared with the apps that need them. Everything in this diagram has a purpose, and every relationship you see here is directly reflected in the code. So that's all for our UML diagram. Next one is the core of our code. So this is the smartphone class, which will be explained by Rex de Gracia.
For the wonderful explanation of class diagram, Mr. ESCUETA. Now, I will explain the first class of the system, but let me introduce myself first. I am Rex de Gracia, and this is the smartphone class. Think of this as the phone itself. It doesn't browse the internet or take photos on its own, but it holds all the hardware that the apps need to do those to do to do those things. It also keeps a list of all installed apps, like first the constructor and builds and constructor. All the hardware will are private. The encapsulations. The apps can't directly touch the camera or the speaker. They have to go through the phone's tether methods. The app's list is typed as list application. The specific app type does what let us store any kind of app in one list. Then then we move to the start phone and install app. First, the start phone. Public voice start phone power status equals true. Then install app. Public voice install app application app. If app is equal to null, throw you in the argument exception cannot install a null app. When the phone starts, it immediately connects to the internet, just like a real phone, also connecting to Wi-Fi. And before installing an app, it checks if the app is null. That's defensive programming. You ask a bad input early so you don't get weird errors later. Then, public voice open up. This is the most important in the whole program. If yes, if the phone is on, then drop the app. At the given index and scrolls open and execute on it. Here's the interesting part. It doesn't know if it's a browser app or a camera app. It just calls the two methods. The correct version runs automatically based on whichever app is stored there. That's right, there is a polymorphism. That's all for the smartphone class. The next class will be explained by Mr. Consorte.
Hi everyone, now I'll be explaining another class from our project called Camera. So this class is very simple and represents a camera components in the system. Inside the class, we have one method called capture photo. This method does not take any parameters and does not return any value. When the method is called, it prints the message camera photo captured. So this simulates the action of taking picture using a camera. So basically, this class models a basic camera functionality where calling the method triggers a photo capture action. So even though it's simple, this class can be used together with other components in larger application like multimedia or mobile system. So let's proceed to the another class. Now, I'll be explaining the network module class from our project. So this class is responsible for handling internet connectivity and data transmission. So as you can see, first we have a private Boolean variable called is connected. This variable keeps track of whether the system is currently connected to the internet or not. Next, we have the connect internet method. So when this method is called, it sets is connected to true and prints message connected to internet. This simulates establishing an internet connection. Then we have the send data string data method. So this method is used to send data over the internet. Before sending the data, it checks if the device is connected. If is connected is false, it throws an error using illegal state exception with the message no internet connection. This ensures that data can only be sent when there is an active connection. If the system is connected, it proceeds to print sending data, followed by the actual data. Then finally, we have the is connected method. So this is a getter method that simply returns the current connection status. So overall, this class simulates a basic network system where you connect to the internet, you send data only if connected, and you can check the connection status anytime. So next is another class. Next, I'll be explaining the speaker class from our project. This class represents a speaker component that is responsible for playing audio. So inside the class, we have one method called play sound, which takes a parameter called sound. So this parameter represents the name of the audio file to be played. Before playing the sound, the method performs a validation check. It checks if the sound is null or empty. If it is, the program throws an error using illegal argument exception with the message, sound cannot be empty. So this is important because it prevents the system from trying to play an invalid or missing audio file. If the input is valid, the method proceeds to print speaker playing, so followed by the sound name. So this simulates the speaker playing the audio. So this class ensures that only valid sound inputs are accepted, errors are handled properly, and audio playback is simulated through output. So next class. Now, I'll be explaining the storage class. So this class is responsible for handling file storage operations such as saving and loading files. First, we have the save file method. So this method takes a parameter called file, which represents the name of the file to be saved. Before saving the file, the method performs a validation check. It ensures that the file is not null or empty. If the input is invalid, it throws an error using legal argument exception with the message invalid file. If the file is valid, it prints file save, followed by the file name. So this simulates saving a file into storage. Next, we have the load file method. So this method also takes the file name as a parameter. Unlike the save method, this one does not perform validation. It simply prints storage file loaded followed by the file name. So this simulates retrieving or loading a file from storage. So this class handles basic file operations where files can be saved with validation and files can be loaded for use in the system. So the next class, Uno Dalmacio will
Thank you,
gonna
John A.
explain the
Now,
application
let
class.
me explain the foundation that holds everything together, the application abstract class. So just think of application as a template or a blueprint. It defines what every app in our smartphone must have and must be able to do. But it does not do the work itself. That is the job of subclasses. So first, notice the word abstract. This means you cannot create an application object directly. You are forced to use one of its subclasses like the messaging app or call app like this that we have here. The field app name is declared as protected. This means subclasses can access it directly, but it is hidden from outside classes. This is encapsulation. We protect the data and control how it is accessed. And for this class, we also do have here the constructor. So in our constructor, it has a validation. So if someone tries to create an app with an empty name, it will throw an error immediately. This protects the integrity of our data, which is another example of encapsulation. And now we have here the methods, the public string get app name, and execute and open. So the method execute is declared as abstract, meaning it has no body here. Every subclass is required to provide its own version of execute. This is how we define a contract. We say every app must know how to execute, but we leave the details to each specific app. And another is the open method, which is not abstract. It has an empty body, and subclasses can choose to override it with their own behavior, and this gives flexibility to the design. This is the power of abstraction. We hide the complex details and only show what is necessary at the top level. And now, let's look at our first concrete app, which is the messaging app. Messaging app is a subclass of application. So, it inherits everything from application, the app name field, the get app name method, and the structure of open and execute. It also it also has its own field, a network module object. This is composition. Messaging app uses a network module to do its job. The network module is passed in through the constructor, which is called dependency injection. In our constructor, we have here the word super, which means all the the messaging app up to the parent constructor in application will be used here in our class. So the validation we saw earlier will run automatically here. And here in our override methods, messaging app is providing its own version of open and execute. When execute runs, it calls send message method, which uses the network module to send data. So when the phone opens the messaging app, two objects are collaborating, the messaging app object and the network module object. This is exactly what OOP is about. Objects working together. And next, we have the call up class. It also has an extend keyword, which means it inherits all the things in application class. So just like messaging app, call app also extends and uses a network module. This shows inheritance in action. Both apps share the same parents and follow the same contract. So here in our method, we also override, but look at execute method. Instead of sending a message, it makes a phone call. This is polymorphism. Both messaging app and call app have an execute method. But when we call, they do different things. In smartphone class earlier, when open up is called, it does not know whether it is opening a messaging app or call app. It simply calls app.execute method. And Java automatically runs the correct version depending on which object it is. That is the beauty of polymorphism. To summarize my part, application give us abstraction and encapsulation. Messaging app and call app demonstrate the inheritance and polymorphism. These three classes together form the foundation of how our entire smartphone simulation is built. Now, I will pass it to Rex to continue with our browser app and camera app.
Thank you for the explanation, Mr. DALMACIO. Now, let's look at the browser app class. This is the internet browser on the phone. What's important here is that it doesn't do network stuff by itself. It borrows the phone network module to actually send data. First, public slash browser app extend application. The extend application part means it inherits from the parent class. It's just app name and get app name. For free without rewriting, that shows it only needs to fill in its own open and execute. The next is the super browser app. The super browser app just passes the name of the application constructor, where we're using the parent's logic instead of duplicating it. The network module is passed in through the constructor. This is called dependency injection. Browser app doesn't create its own network, it uses the one on the phone provides. When browse internet runs it calls network and that and data to simulate browsing. The next is the camera app class. This one is a bit more interesting than browser app because it depends on two things, the camera hardware and storage. To take a photo, you need the camera to capture it, and then somewhere to save it. Both are passed in through the constructor. Private camera, camera, private storage, storage. Public camera, 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 storage, and so on. Super camera app. Business camera equals camera. Business storage equals storage. Two private fields are called camera and storage. Both are injected through the constructor. Same pattern as browser app. The phone owns the hardware, it just sends it to the app when it installs it. When public void executes a photo runs, it calls take photo that method does two things in order. Camera that captures photo that takes picture that takes the picture, then storage the sync file, photo the sync mini. The sync means two separate objects working together of with one action. That's all for the camera app. The next task will be explained by Mr. CONSORTE.
Hello everyone. So now I'll be explaining the class called Music App, which is part of our project. So first, let's look at the class declaration. The Music App class extends another class called Application. This means Music App inherits properties and behaviors from the application class, allowing it to act like a type of application. So next, we have the private attributes, which is the speaker and storage. So the speaker is responsible for playing sounds. The storage is used to load or retrieve music files. These are passed into the class through the constructor. So in the constructor, we also call super music app, which sends the name of the application to the parent application class. Now, let's move to the methods. So the first method is open. This method overrides a method from the parent class, and it simply prints music player open. So this simulates opening the music application. The next method is execute. This is also an overridden method, and it defines what happens when the app runs. In, in this case, it calls the play music. So this is the method and plays a file name song.mp3. Now, the functionality is in the play music method. So this method takes a string parameter called song, which represents the file name. So inside this method, the important actions happen. First, the storage that load file song, which loads the music file from storage. Then, speaker that plays sound song plays the sound through the speaker. So this class simulates a simple music player where the storage retrieves the music file, the speaker outputs the sound, and the application controls the flow. So now, Kaisler Escueta will going to explain the main class.
So before I start, I want to thank John Paul Consorte for that very detailed explanation. So now let us walk through the actual output of our simulation and trace each line back to the code that produced it. So this is produced when the main class calls. So this is the first test case. So this is produced when the main class calls the phone that start phone. Looking at the smartphone class, the start phone method sets power status to true. So prints phone started and then immediately calls network that connect internet, which is what produces the second line. So with a single method call in main, the phone is powered on and connected to the internet. So in the second setup, so installing apps on the phone. So these are produced by the install app method inside the smartphone class. Each time's install app is called, it first validates that the app is not null, and if it passes, it adds the app to the internal apps list and prints the confirmation message using app.getAppName. This is why the names appear in the exact order they were installed in the main. This one. So messaging app and the call app, music app, browser app, camera app, and then it prints all apps installed successfully. So in the next stage, user opens a communication feature which is messaging. So this is where the simulation becomes interactive. Each app is opened using phone.open app, passing in the next passing in the index of the app. Looking at the open app method in the smartphone class, it does three things before the app even runs. First, it checks whether the phone is powered on. If power status is false, it throws an exception. Second, it validates the index to make sure it is within range. Third, it retrieves the correct app from the list and prints, which is the opening app name. That is why every app section in the output begins with a user opening line. It comes from directly in the open app method, not from the app itself. So after that, open app calls to method on the app, open, then execute. So the remaining lines in each section are produced by those two calls. So let us go through each app one by one. So messaging app is after the opening line from open app. We see app opened from the open, then sending data hello and message sent from the execute. So call app is open method which prints dial pad opened and then execute, sends data through the network and prints calling 0912345678 music app. So before open app is even called, main prints a line about activating the speaker and storage subsystems. Then open prints player opened and execute loads the file from storage and plays through it through the speaker, producing the last two lines of the section. So the browser app similarly main prints the network activation notice first, and then open prints opened and execute sends a browsing request through the network module. So camera app main again prints the subsystem activation notice, then open prints camera app opened and execute triggers take photo, which calls camera dot capture photo, producing photo captured, followed by storage dot save file, producing file saved photo dot jpg. So our key observation is that in every single case, the smartphone class acts as the gatekeeper. It is the one that checks if the phone is on, validates the index, retrieves the correct app, and initiates the open and execute sequence. The main class simply provides the index. It has no knowledge of what happens after that. All coordination is handled internally. This is what makes the design clean. The output we see on screen is not just a series of print statements. It is a direct reflection of how responsibility is distributed across the system. So that concludes the walkthrough of the main class and its console output. So thank you sir for listening. So this is our project about smartphone. So every line you saw printed has a clear origin in the code, and every component played exactly the role it was designed for.